Trigonometric identity, SOHCAHTOA. Sine of an angle is a ratio of sides, the opposite side divided by the hypotenuse. The hypotenuse in a right triangle is the longest side, the side opposite of the right angle. So in this right triangle, 5 is the hypotenuse. It's opposite the right angle. So cosine is adjacent over hypotenuse. The adjacent side, the side that's next to the angle, that's not the hypotenuse, divided by the hypotenuse. And tangent is opposite over adjacent. The opposite side, the side that's opposite of the angle, divided by the length of the side that is adjacent. So let's look at this triangle, this sample triangle right here. And these little letters are the angles, A and B. So sine of A is equal to opposite, 3 is opposite of A, divided by hypotenuse, the longest side, which is 5. So sine of A is 3/5. Cosine of A is adjacent, the side that's next to angle A, so that's 4, divided by 5, the hypotenuse. And tangent of angle A is equal to the opposite, 3, divided by the adjacent, 4, 3/4. Now, here's an identity that's important to know. Tangent equals sine divided by cosine. And if you want to do that with the sides, it's the opposite over hypotenuse divided by the adjacent over the hypotenuse. Remember, if we're dividing by a fraction, down here, you flip it and multiply. So it's the same thing as multiplying by hypotenuse over adjacent. Hypotenuses cancel. We get opposite over adjacent. That's tangent, opposite over adjacent, or sine over cosine. That's a good identity to know. Now, there's something that go with these that not tested too often, but sometimes. You have what's called secant, cosecant, and cotangent. Those are just the reciprocal fractions. So secant of A, reciprocal means you flip it, is going to be hypotenuse over adjacent. So in this triangle, for A, it's going to be the hypotenuse divided by, did I say adjacent? Hypotenuse divided by opposite. So notice, the sine of A is 3/5. The secant of A is 5/3. It's just flipped. The fraction is flipped. And hold on. We made a mistake there. Secant actually goes with cosine. Cosecant is sine flipped. So that would be 5/3. Secant would be the cosine flipped. So that's going to be hypotenuse over adjacent. I think I somewhere got confused in there. So let me say it again. Secant is cosine flipped. Instead of adjacent over hypotenuse, it's hypotenuse over adjacent. So in this case, the secant of A would be 5/4. That's the hypotenuse divided by the side next to the angle for little angle A. And then cosecant would be hypotenuse over opposite 5/3, and cotangent, I think I'm going to have to scroll down a little bit and maybe move this thing so there's more room for it. Cotangent is 1 over tangent, or tangent flipped, 4/3. And that's the other thing to remember. Secant is equal to adjacent, hypotenuse over adjacent, or you could say it's 1 over cosine. Either way. Cosecant is equal to hypotenuse over opposite, or you could say it's 1 over sine. And cotangent is adjacent over opposite, or you could say it's 1 over tangent. So those are basic trigonometric identities. The trigonometric identities, or SOHCAHTOA, initially are just ratios. They're one side divided by another side. One other one you can remember is that sine squared plus cosine squared equals 1. There's other trigonometric identities shown on that cheat sheet, but these are the ones to remember. Of course, all the trigonometric ratios. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. And then you have secant, which is 1 over cosine, which is hypotenuse over adjacent. Cosecant is 1 over sine, which is hypotenuse over opposite. And cotangent is 1 over tangent, adjacent over opposite. And then sine squared plus cosine squared equals 1. Sometimes it's written like this: 1 minus cosine squared equals sine squared. Or it's written 1 minus sine squared equals cosine squared. One other thing you have to remember, and you can just memorize this, is what's called the unit circle. These are separated into quadrants. The coordinate plane is separated into quadrants. And remember, sine and cosine and tangent and cotangent, all those things, all those trigonometric ratios keep repeating. They go over and over and over again, hitting the same values. So we separate the coordinate plane into these quadrants, and they're numbered like that: 1, 2, 3, 4. And then remember this: C down here, A in the first quadrant, S in the second quadrant, T in the third quadrant. And that tells you which of these functions are positive there. A means all are positive. So sine, cosine, tangent, and then secant, cosecant, and cotangent are all positive there. S in the second quadrant means only sine, and then the one that goes with it, cosecant, are positive. All the other ones, tangent, cosine, secant, cotangent, are negative in the second quadrant. In the third quadrant, only tangent and then cotangent, the one that goes with it, the one that's 1 over it, are positive. Sine, cosine, secant, cosecant, all negative in the third quadrant. And in the fourth quadrant, only cosine and secant are positive. All the other ones are negative. Now, how do we know what's in the first quadrant, second quadrant, third quadrant, fourth quadrant? Well, you can either go by angles or what's called radians. If you don't understand radians, just memorize this. This is 0 degrees. It's also 360 degrees, because remember, it just keeps happening over and over again. And it's also called 2 pi degrees. 2 pi is radians. Up here is 90 degrees, or pi over 2 radians. This is 180 degrees, or pi radians. And this is 270, or 3 pi over 2. Memorize that unit circle. Memorize C, A, S, T. It tells you which ones are positive and negative. And memorize the quadrants: 1, 2, 3, 4. You could also write these things: 2 pi is 2 pi, pi over 2. You could also write that as 1/2 pi, 0.5 pi, or 1/2 pi. Pi is just pi, 1 pi, and 3 pi over 2. You can write that as 1.5 pi. You might have to use that for some questions. So just memorize that unit circle. All right, let's go into some examples from the actual test. And if you need to look at all this information again, be kind, rewind, go back to the beginning of the video and watch it again. You could also look up on YouTube SOHCAHTOA, SOHCAHTOA, and get a different explanation of it. Or again, watch mine again. All right, I've got some examples. Let me find examples. And let's see, 72E, number 31. Let's go away from here, and I have to go to official. Where are my official ACT tests? 72E. 72E. Okay. And again, it said, hopefully I have these numbers right, 72E number 31 should be an example of SOHCAHTOA, just the ratios. And this is, again, only for right triangles. Now we're going to talk about in a little bit the law of sine and law of cosine. Those are for all triangles. But this is for right triangles. Okay, where's 31? 31, please. All right, triangle ABC shown below. Sine C is 4/5, and the length of AB is 10 inches. All right, let me try to draw this thing. Hopefully I've given enough room here. And I have to go back frequently to remember. So this is A, this is B, this is C. It says this is the right angle. So remember, the sine opposite the right angle is the hypotenuse. That's the longest side. We don't know how long that is, but we know AB is 10. And then it says that sine of C, so C is this angle. If they don't write the angle inside, it's just the angle named for the vertex. So that's C. Sine of C, it tells us in the question, is equal to 4/5. Well, we also know sine of C from SOHCAHTOA. Sine is opposite over hypotenuse. So the side opposite C is 10. That's opposite C. So that's also the same as saying it's 10 divided by hypotenuse. This side is hypotenuse. AC, the one we're looking for, is the hypotenuse. It's opposite of the right angle. So I'll just use question mark as the variable. So now we know that the sine of C equals 4/5. That's what the question told us, which is also equal to 10 divided by the hypotenuse. Opposite over hypotenuse, which we don't know. So how do you solve this when you have one fraction equal to another? Cross multiply. 4 times question mark equals 5 times 10, which is 50. Question mark equals 50. Just divide both sides by 4, which you can simplify. Divide them both by 2. 25 over 2. So that is answer choice E, 25 over 2. So that's a simple question just with the trigonometric ratios. All right, let's go to another one. Let me see. We want to save law of sine and law of cosine for a moment. Let's look at these different things with cosecant, secant. This is B04, number 44. So let me close this one, and I'll leave that open. B04, number 44. How do I search? B04. Here is B04. I have many, many tests. 80-some tests. B04, and then it says number 44. Sometimes I miswrite these numbers, so we have to be clever. 44. It says for all real values of x, such that 0 is less than x is less than pi over 2, which of the following expressions is not equal to tangent? Okay, and then we have different choices. Now remember, the unit circle. Here's 0. Here's pi over 2, or 90 degrees. So we're in the first quadrant. It says 0 is less than x is less than pi over 2. So we're in the first quadrant. Everything is positive here. So sometimes it's wise to write that down to know what quadrant you're in. We're in the first quadrant. And remember another ratio, I won't scroll up this time, but it's up there. Tangent equals sine over cosine. That's one way to write tangent. It also equals opposite over adjacent. So we can use either one of those to try to figure these things out. All right, let's look at 1 over cotangent, F. 1 over cotangent. Well, remember, you may remember from what we said, cotangent is 1 over tangent, which means tangent is 1 over cotangent. So that one is equal to tangent. So that's not an answer because it says which one is not. You could also do it this way. Remember, cotangent is adjacent over opposite. And when you're dividing by a fraction, you just flip it and multiply. So this would be the same as 1 times opposite over adjacent, which is just equal to opposite over adjacent, and that equals tangent. So F is not the answer because we're looking for the one that does not equal tangent. All right, let's look at G. Secant over cosecant. Secant over cosecant. I won't put the x's in, but normally you put the x's. So we can do this two ways. We can use the sides in the ratios, or we can just use how secant and cosecant relate to sine and cosine. Let's do that one first. So remember, secant is 1 over cosine. Cosecant is 1 over sine. And when we divide by a fraction, we just flip it and multiply. So that's the same as saying sine divided by 1 times sine divided by 1. Multiply top times top. 1 times sine is sine. Multiply bottom times bottom. Cosine times 1 is cosine. And cosine, sine over cosine is tangent, so G is not our answer because we're looking for the one that's not. Let's use the ratios. Secant, I'm going to write this over here, secant is hypotenuse over adjacent. And we're dividing that by cosecant, which is hypotenuse over opposite. Remember, that's up here. They're like flipped. Secant is cosine flipped, or it's 1 over cosine. Cosecant is sine flipped. It's 1 over sine. So again, when we divide by a fraction, we flip it and multiply. Opposite over hypotenuse. We can cancel the hypotenuse, and we get opposite over adjacent, which is equal to tangent. And again, we're looking for the one that's not equal to tangent, so G is out. I'll tell you another way to do this momentarily, and maybe a simpler one, even if you don't remember all these ratios. Okay, sine over cosine. Well, I won't even do that with the ratio of sides because that's something you should memorize. Sine over cosine is equal to tangent. It just is. So H is not our answer. That's equal to tangent. All right, J, you can see it circled here. J is the answer, but cosine x times cosecant. So cosine, I just don't write the x's, but you really should, times cosecant. Okay, let's use the sides on this. Cosine is adjacent over hypotenuse. Cosecant times is hypotenuse over opposite. Hypotenuses cancel. This is adjacent over opposite. This isn't tangent, it's tangent flipped, which is actually cotangent, which is 1 over tangent. So that one's not equal to tangent. J is the answer. And then we have K, sine times secant. I don't put the x's because I like to just save a little time. Sine times secant. I'll use the ratios. Sine is opposite over hypotenuse times secant, which is hypotenuse over adjacent. The hypotenuses cancel. That's opposite over adjacent. And that is tangent. So SOHCAHTOA, tangent is opposite over adjacent. Another way you could have done this is pick an angle between 0 and pi over 2. Now, you can set your calculator if you have a TI-83, TI-84 into radians mode, and then pick a value that's between 0 and pi over 2, like pi over 4. Well, maybe you don't know radians, but you know pi over 2 is 90. So pick a number between 0 and 90. If you're in degrees mode, you could do 30 degrees. And then use 30 degrees and do 1 over cotangent of 30 degrees. Secant of 30 degrees for G over cosecant of 30 degrees. And see which one of those equals tangent of 30 degrees, or which one doesn't equal tangent of 30 degrees, and that will be your answer. But here's how to do it with all the ratios. And we found out that the answer was J. Okay, so that's a little bit of an advanced topic. If you can't figure that one out, watch it a few times. But that one is not going to kill you. It's if you need a perfect score, or if you can figure it out or follow it, then it's going to help you by working some tougher questions and get you extra points. But the main thing to try to learn here, the main thing to remember is SOHCAHTOA, and then here's your example of SOHCAHTOA, and then the unit circle, very important too. So, all right, let's do one more example. Let's see. Have I done this? Unit circle. Well, let's do unit circle. 73G number 51. All right, let me close this one. And then, wait a minute. 73G number 51. Oh, we have many, many examples. 73G number 51. So this is an example of the unit circle. If you know the unit circle, now this is one of the toughest ones from 50 through 60. But if you know the unit circle, you can get this one really easily. What are the values of theta between 0 and 2 pi when tangent theta is -1? All right, let's first look at the unit circle. They want between 0 and 2 pi. So they're talking about the whole unit circle. Here's 2 pi. It is also 0. You could also call it 180. And they say between 0, remember, on the unit circle, positive angles go counterclockwise. So between 0 and 2 pi, all the way around the unit circle. Well, remember, C, A, S, T. They want values where, what are the values of theta between 0 and 2 pi when tangent is negative 1? The only place tangent is negative is here in the second quadrant and here in the fourth quadrant. And remember, this is pi over 2. We could also call that 0.5 pi. This is pi, and this is 3 pi over 2. Or you could call it 1.5 pi if you'd like to. Just you can keep things straight. So let's check this out. It says pi over 4. Well, pi over 4 is 0.25 pi. It's somewhere over here, between 0 and 0.5 pi. Tangent is positive in that quadrant. So A can't be an answer, and pi over 4 can't be one of the answers. So that means A is out and E is out, just by looking at pi over 4. Let's look at B, 3 pi over 4. Well, do 3 over 4 in your calculator. You'll find out that's 0.75. Well, 0.75 is between 1 and 1/2. It's up there, so tangent is negative. It could be 3 pi over 4. So 5 pi over 4 is the next one. 5 divided by 4 is 1.2. 1.2 is over here somewhere between 1 pi and 1.5 pi. Tangent is positive there. So 5 pi over 4 is out. So again, we've eliminated now B, because 5 pi over 4, tangent can't be negative. It's in the wrong quadrant. And D also have 5 pi over 4. So now we've eliminated everything except C. And C is the answer. 3 pi over 4, we already found out 0.75 pi is in the second quadrant, where only sine is positive, tangent is negative. So tangent can be negative there. And then what's 7 pi over 4? Well, what's 7 divided by 4? I have to do it here. 7 divided by 4. You could use your calculator. I'm just going to do it this way. 4 times 1 is 4. And then 30. And then 4 times 7 is 28. And then this is 20. And 4 times 5. So that's 1.75. That's going to be here somewhere, where tangent can also be negative, because only cosine is positive there. So without even figuring out the values, we found out that C is the answer. You could also just plug this into your calculator. Put it in radian mode and do tangent of pi over 4, tangent of 3 pi over 4, and see what the answers come out to. You'll find out. But you don't even have to do that if you memorize the unit circle. And if you don't get it 100%, it could be clear as mud. That means it's not clear at all. Clear as muddy water. This is what the nuns used to say. Clear as muddy water means so-so. And then clear as water, you see it crystal clear. Well, if it's not crystal clear, rewind the video again and watch it. Or go to the internet again, to YouTube, and look up the unit circle. But this is a good example of a unit circle question. All right, what else we got? That's it for those trig identities, but they gave some other things on that trig identity page that I wanted to talk about. And this is, now remember, these ratios, SOHCAHTOA and all this stuff, works for right triangles. There has to be a right angle in it. The law of sine and the law of cosine, which are also tested, are for any triangle. They do not have to be right triangles. Now, look at the difference in the formula. Law of sine is a very short formula. A, that means that's a side. Notice in my triangle I have A is a side, little b is a side, little c is a side. And then big A is an angle, big B is an angle, and it's hard to tell the difference between a little, I'll try to make this C smaller so we can tell the difference. But so, it doesn't really matter which one's big or small as long as you're consistent. But we're calling the angles the big letters and the sides the small letters. So notice, small c is opposite of the angle C. Small a is opposite of the angle A. So it's the side opposite of the angle. And this formula says that the side divided by the side of the angle opposite of the side equals another side divided by the sine of the angle opposite it equals the other side divided by the sine of the angle opposite it. So with law of sines, if you have a side and the angle that's opposite it, or the angle and the side that's opposite it, and then they give you one other thing, if they give you a side and you need to find the angle opposite of that, then you can use the law of sines. Or if they give you an angle and you need to find the side opposite that, provided that they've given you a side and an angle opposite it, you can use the law of sines. Any other situation, you have to use this long formula. And most of the time on ACT, you're not going to have to calculate the long formula. You just have to recognize it. And the important thing to remember is this. We always call C squared and C. We call it the thing we're looking for, what we're taking the cosine is of when we're doing the law of cosines. So C squared on this side, this is the side opposite of the angle. One of those two things is going to be the thing we're looking for. So I mean, you can write this you can say A squared equals C squared plus B squared minus 2CB cosine A. So notice again, the thing on the left side, the side that's squared is opposite of the angle you're taking the cosine of. That's the law of cosines. You can draw it one way and just say, okay, C, that side or that angle are always going to be the one thing we're looking for. Hold on now. My computer is going haywire. Let me get, what am I doing? There we go. Computer was going haywire. Okay, so again, if you have an angle in the side opposite it, and you have another angle and you're looking for the side opposite of it, or you have another side and you're looking for the angle opposite of it, use law of sines, the short formula. Any other situation, you have to use the law of cosine. And whatever side is on the left side, the angle opposite it is what you're taking the cosine of on the right side. And then the squared, those are the other two sides squared, minus 2 times the other two sides squared. That's not supposed to be an equal, that's supposed to be a minus. Okay, so how do we actually do questions with this? All right, let's see. I have a law of sine question, 71C, number 44. So let me close that and go here, 71C. Number 44, please. And for some reason, it always likes to open that little menu on the side. I don't want it. Number 44. Okay, it says Lee is standing at point L on the north side of the small canyon shown below. The measure of angle S is 28. Which of the following equations, when solved, gives the measure of angle T? And then they give you the law of sines here. All right, let's check it out. And let me see if I can redraw this. I won't put all the little landmarks in. I'll just draw the triangle. And then they say this is T, this is L. Wait a minute. It's not drawing the up L. And then this is S. And then the only angle they give us is 28 degrees. And then they tell us that this is 2 and this is 3. So notice the situation. And you didn't have to choose it here. They only gave you the law of sines, but even if they didn't, you'd know to use it because you have an angle and the side opposite it, and you've got another side, and they want you to find the angle opposite the other side, the side 3 in this case. So this is law of sines. We can put sine of 28 degrees divided by the side opposite, which is 2, equals the sine of whatever that angle is, sine of angle T, divided by 3. And I think in this case, that is actually the answer. F, sine of T over 3 equals sine of 28 degrees over 2. So sometimes they might not do that. They might actually ask you to solve this. This is going to be kind of a little bit of an advanced topic. You can try to figure it out if you want. If you can't, they hardly ever ask this. But you never know. They might say, okay, they actually want a solution for T, and they'll draw the formula a different way. So in order to get sine T by itself, we multiply both sides by 3. We get 3 sine 28 degrees divided by 2 equals sine of T. Okay, but what if I want to find what T is? What is that angle T? Well, we have these functions called arcsine arc cosine, arc tangent. And there's also arc secant, arc cosecant, arc cotangent. Sometimes they're written like this, arc, A-R-C-S-I-N. And then arc cosine and arc tangent. And what those mean is, remember, SOHCAHTOA, sine of an angle is opposite over hypotenuse. Well, this gets the angle. If we know what the opposite and hypotenuse are, and we take the arc sine of it, that's going to give us the angle, whatever we'll just call the angle x. That's going to give us the angle that has the sine equal to that opposite over hypotenuse. So in other words, if I wanted to solve this one for t, I would just do arc sine. 3 sine 28 degrees over 2 equals, and then remember, all these arc sine, arc cosine, arc tangent, they're the inverse functions of sine, cosine, tangent. So arc sine and sine undo each other. They just cancel each other out. So that would equal t. So arc sine of 3 sine 28 degrees over 2 would equal t. However, you didn't have to do that with this one. You don't really have to worry about it again unless you're going for a perfect score. But if you want to, and you want to memorize it and understand those, watch this part of the video again, and then you'll have even the arc sine, arc cosine, and arc tangent. But there is an example of law of sines. Let's do an example of law of cosine. E23, number 58. E23, and don't worry, this is the last thing on this video. E23. Look how many tests I have. E23, number 58. It seems endless. There's just an endless array. E23, number 58. Now, for someone who doesn't need a perfect score, for someone who doesn't need to score beyond the mid-20s, you don't have to do 51 through 60. I would skip them. However, and usually law of sine and law of cosines are going to be 51 through 60. So just check it. See if there's a law of sine and law of cosine question. Know those so that you can answer them, and it's almost like a bonus. It'll be a bonus. I'd say the sides of an acute triangle are 17, 16, and 15. All right, I'm going to draw this triangle. 17, 16, 15. And then it says, the measure of the smallest angle of the triangle is a solution for A to which of the following equations? So I guess they want to call it angle A. Well, which angle is angle A? The smallest angle is always opposite the smallest side. And the largest angle is opposite the largest side. And the middle angle is opposite the middle side. So notice, I don't have an angle in the side opposite. I don't know what the angle is. I'm looking for this angle A, but I don't know how many degrees it is. So I do not have an angle in the side opposite it. I have to use the law of cosines. And the law of cosines is the side squared, the side opposite of the angle that I'm interested in, squared, equals, and then the other two sides, 17 squared plus 16 squared minus 2 times the other two sides. And now we fit the law of whiteboards. No matter how big the whiteboard is, I always run into the edge of it. And then it's going to be times the cosine of the angle we're looking for, the angle that's opposite of the side that went over here and was squared. So that's what it should look like. And let's see, 15 squared. Well, look at F, G, and H have the wrong thing squared because 17 and 16 are not opposite of the smallest angle. So this is 15 squared. And what's the difference? J has sine of A. And this is the law of cosines. So the answer is K. And notice this time they didn't tell you to use the law of cosine. So you just had to recognize. Of course, all the answers look like the law of cosine except for F and J, which have sine in them for some reason. So the answer on this one is K. All right, there you go. There is some information from the cheat sheet on various trigonometric ratios and concepts, including the law of sine and the law of cosine, along with some questions for each. So if you don't understand anything, Look up some other videos. Watch this video again. That is all.